Hello class, I'm here to talk about the last problem for the term, chapter 6. I know everyone is working on their final exam, but I thought I would present a chapter with more variables and some new formulas that we're going to be using Solver. And I've chosen problem 5 from chapter 6. So let's read it. Actually, if you notice on question A, it asks us to develop a network representation for the problem, which I have done here in Excel. And I'm gonna go over right now by reading the problem, and we're gonna be working on it. So the problem, let me just put it down here. Okay, so the problem reads, Premier's Consulting, two consultants, Avery and Baker, can be scheduled to work for clients up to a maximum of 160 hours each over the next 4 weeks. A third consultant, Campbell, has some administrative assignments already planned and is available for clients up to a maximum of 140 hours over the next 4 weeks. The company has four clients with projects in process. The estimated hourly requirements for each of the clients over the 4 week period are as follows. So right here we are presented with a table for the maximum hours that clients are allowing for the consultants to work. So we have for client A, we have a maximum amount of 180. For client B, we have 75. For client C, we have 100. And for client D, we have 85. If you look right here, the total, this column is going to be the total for each consultant. And the way we're going to be defining that is by reading the problem again and saying that Avery and Baker can be scheduled to work for clients up to 160 hours. Therefore, Avery maximum, not total, maximum is 160. Baker is going to be 160. And for Campbell, a third consultant, Campbell has some administrative assignments already planned, is available for clients up to 140 hours. So that's going to be our uh, maximum allowed for Campbell. Why do we need this? Because this is actually going to be the total for our constraints, no more than these hours. Consultants cannot work more than the maximum allow hours on this column. And also, clients do not permit the consultants to work more than this amount of hours. Okay, this other little table right here, those are the rates, how much they're getting paid per hour, which if you keep reading the problem, it says the hourly rates vary from the consultant client combination and are based on several factors, including project type and consultant's experience. The rates per dollar for each consultant client combination are as follows. And all I did, I just copy this little table right here with the rates, the consultants right here, client A, B, C, and D, and here are the dollar amounts. Okay, so now it's asking us to develop a network representation, which I basically have done here, and is asking also to formulate the problem as a linear program, which is the optimal solution providing the hour each consult should be scheduled for each client to maximize the consulting firm's billings. What is the schedule and what is the total billing? So since it is asking us for the total billing in dollar, I have put it down here, the total revenue, that's going to be our objective that we need to set up. And this is going to tell us how many hours each consultant is going to work for each client, not passing this total amounts right here. Okay, so let's start working on it. If you remember, we need to set up an objective for Solver on the total revenue. Usually what we do, we are going to do consultant A, Avery, 100 times right here, the hours, and then plus the second one times Baker, plus the third one times Campbell, and continue. The easiest way that we can do that with Excel is with a formula called sum product. Sum product is going to do exactly the same thing once we select this table and have put exactly the same amount of cells right here. So it's going to automatically multiply and add for us. So let's go and do equals sum product. And then when you type it, it's gonna ask you for array one. Array one is gonna be this table right here. It's gonna be the dollars amount, and you're gonna do comma, see right here on the formula, and then you're gonna put the second table right here. Those are gonna be the hours that the problem solver is gonna indicate to us what are gonna be the optimal hours for each consultant and each client. We close that. For now, since we don't have anything here, you're not gonna have an amount. However, should you have anything here, you're gonna notice how it's gonna change the total revenue because it's multiplying. See right here, Avery, if I put 10 hours, is multiplying by the 125 rate, so it'll be 1250. But this is gonna be determined for us using solver. So here you have, when you look, remember, if you remember, we have always the left hand side and the right hand side for a constraint, and then we have this sign in the middle. So these amounts right here are all for your right hand side. So we're going to be using this first, and then we're going to be using these values. Okay, so since we have a maximum of hours allowed, all your signs are going to be less or equal than, all of them. The left side, it's going to be the total for each column. So the total for Avery cannot go over 160, and the total for client A cannot go over 180. So let's put that as a constraint. So the total right here of Avery is going to be the sum of the total hours for each client. So let's do equals to sum, and then we just select the cells. So this is going to tell us the total amount hours for Avery. And then we just have to copy down the formula. So now right here is giving the sum B10 right here all the way to D10, actually E10, which is client A, B, C, and D. And then here the same. So now we did the rows. Now we have to do the total for the columns. So let's do the same thing. Let's do the sum. And then right here, we're gonna do these three. So now you have the total for client A, and then you just copy the formula across. And then you have the total for client B, and then the total for client C, and the total for client D. I'm not being very detailed with this problem because you're not gonna be submitting this as your homework. I just wanna show you how to solve one of the problems for chapter 6. Let's go now into the constraints. You know that this constraint right here, the total for Avery, it gotta be less or equals to 160. Then your total for Baker, and I'm gonna copy this sign right here. It's gonna be less or equals to 160 as well. And your total for Campbell is gonna be less or equals than 140. Those are hours. Maximum allow hours for consultants. Now we are looking at a maximum allow hours for clients. So same thing we're gonna do for client A. It's gonna have less or equals than 180. For client B, my total for client B has to be less or equals than 75. Then the total for client C has to be, oops, see I did a mistake right here. This total has to be less or equals than 100. And then the last one is going to be for D. The total for D is going to be less or equals than 85. Those are my constraints. So now all we need to do is to place that in solver. So let's open solver. So data solver. So our objective is the total revenue, the number of hours multiplied by the number of the dollar amount. For the changing variables, we're maximizing. We wanted the most amount of money, changing these variables right here. Okay, so now our constraints are going to be add all these values here, less to or less or equals to, so you don't have to change your inequality sign, and your constraints amounts right here. Even though it does look really confusing, you can see that basically we just set the objective put the changing cells and set up the constraints, which they are all going to be less to or equals to a maximum amount of hours. You remember that we keep unconstrained variables non-negative. We choose the simple linear programming, and then we click solve. And there we go. If everything goes well, which it did, we get a total of $57,925. And here it tells you exactly how much each consultant is gonna work for each client. Okay, so when you set up your problem, this is going to be basically X1, X2, X3, X4. So you can see Campbell is only serving client A in the total amount that was determined before, 140 hours. Okay, right here, Avery is not going to work any hours for client uh, A, but he's going to be working for client B and C in the total maximum amount of 140, and which leaves him just with 20. So this is going to be your optimal values. So now just to complete the problem, so we have answer A and B, and then C tells you right here, let me go back. She's asking you, so new information shows that Avery doesn't have the experience to be scheduled for client B. If this consult assignment is not permitted, what impact does it have on the total billings? What is the revised schedule? So it's showing that Avery is not going to do any work for client B. So all you have to do right here, Avery is not doing any work for client B, so you can substitute this amount by 0, okay, which is going to change here. And then all you have to do is to click solver. You don't have to change anything else because right here it's always going to multiply by 0. And then you solve, and there you go. It gives you the new amounts. So now your revenue, you went down from 57,925 to 57,525. So if we would change Avery hours, we would be losing $400, which is the difference. So let me put it here, 795, and then we have now 57,525. So that's a difference of 400 for C. And you would be done with problem 5 on chapter 6. Um, if you would be presented with other amounts such as modifying, you can go ahead and modifying any of those or their maximum allowance. Everything else is going to be given to you by solver, so you will not be modifying those on your own or you're going to get an error. Make sure you always check if you're maximizing or minimizing. In this case, we are talking about dollar amounts, so we are maximizing, but you could be talking about you want to reduce costs, then you would minimize it. You're changing variables, you never put anything, those are the ones solver calculates for you. And make sure when you do the constraints, you're always respecting whether it's less or equal or higher or equal or even equal. And don't forget to change right here for the simplex LP. And this concludes chapter 6. There are several other problems that if you do develop a simple network like this that makes it easier for you to see what's going on. Once you put in solver, it's very easy to solve it. Let me know if there are any questions. Thank you.